Yeah, so we're going to talk about code review today. Um, so first, I'd like to hear from you guys. What are the reasons we do code review? Anybody?
Well, for me, the first thing related with code review is the opportunity to know and know your colleague as something like I don't remember the word was, but it's something related with the team, right?
Mm-hmm. Okay.
I think code reviewing is an excellent tool for learning and also for covering each other's backs to make sure that our code has a high level of quality standard, and also that we, comply with some architectural patterns that we want to enforce in the company.
Yeah, great. So I think this relates to what both of you said a little bit. Yeah, the idea of continuous improvement, just continually learning to make our code better and improve our skills. Learning and mentoring. So, I think it's valuable on both sides of that sort of equation. If you're receiving code review, then you're probably learning something, and also giving code review, you can learn things, right? I mean, when you look at someone else's code, maybe you learn a trick that you hadn't known before, or maybe you just learn a new way of thinking about code and evaluating. So it's useful, I think, for both the person doing the code review and the person receiving it. Somebody already mentioned code quality. That's an obvious thing, I think. Reducing the bust factor. Is everybody familiar with the concept of the bust factor? How many people on your team would, if they were hit by a bus, would your team still survive? In the sense that they, that person who got hit by the bus was the only person who knew something. Then you have a bust factor of 1. So by doing code reviews, then your bust factor goes up, and hopefully nobody gets hit by a bus, but maybe they leave the team or the company, and it can have the same effect. It also helps to improve communication, which I think is what, like Gaston said about the architectural stuff. That's one aspect of that, but it can be broader. Just learning to, as you review code from other people, other teams especially, you maybe learn better communication, or you help bridge the communication. And then the last thing, and I'm actually glad nobody mentioned this, because it's often one of the first things that people talk about with code review is to find bugs, but in my opinion, it's one of the least important reasons to do code review. It is true that we find bugs sometimes in code review, but code review is a pretty blunt instrument when it comes to finding bugs. There are usually better ways to find them, such as tests. But I put it on here just because so many people often bring that up. And in fact, when I first started doing code review early in my career, one of the main reasons my team started doing it was to find bugs. And this is even before we had automated tests at all. I didn't do TDD then. We barely wrote any automated tests, if any. So we were doing code reviews specifically for the purpose of finding each other's bugs. So I guess if that's the only reason you're doing code review, that's better than not doing code review, but it's one of the least interesting benefits for me. But let's take a step back. Code review implies that there's some code to review, but why code? What are the reasons that we do code? So I think actually there are basically 4 reasons for changing code. An obvious reason is to add a feature, right? So we want to add a new provider. We want to interface with Kakao, for example. That's a new feature. Fixing a bug is an obvious one also. So we already have a feature, but it's not working quite as we expected. So we need to do some code to fix that. And then the last 2 are kind of related: improving a design. So here we're neither adding a feature nor fixing a bug. We're changing existing functionality to be improved in some way. It could be to use a better design pattern. It could be to make it more readable, to change import loops, or whatever, something like that, where the design of the code is changing. And the last one is to improve resource usage. So this is your typical performance improvement. Maybe you're changing a SQL query to be more efficient, or you're changing from a slice to a map so you could do faster lookups, or whatever it is. Broadly speaking, those are pretty much the only reasons I know of to change code. Now, of course, this isn't talking about the business value to these code changes, but we're going to talk a little bit more about this a little bit later, these 4 categories. thinking of those four things we were just talking about, the feature, bug, or a refactor, in my view, each merge request or pull request should touch one of those and only one of those. So in other words, if you're adding a feature and you discover a bug at the same time, it should be a separate pull request. And the reason for that primarily is to, well, there's several reasons. One is to keep the pull request small, also makes them easier to review. And we'll talk about some more of those factors in a moment. Every change in a pull request should relate to the pull request title or the topic of the pull request. If it doesn't, then you probably should have two pull requests. And so this is another important one. All changes should revert together safely. And this is one reason to keep your features and your bugs in separate pull requests. And your other refactoring, maybe you're changing the indentation or something, putting those in a separate pull request makes a revert much simpler if it's needed. Of course, we hope that they're rarely needed. But if you do end up, say you've added a feature that ends up not working quite right, and you need to revert it so that you stop crashing production. If you've included 3 bug fixes in your pull request, then you've also reverted those bug fixes, which you probably don't want to do. So by keeping your pull request small and isolated, so you have 1 bug fix or 1 feature or 1 refactor per pull request, then in the event that you do have to revert, you haven't reverted other things that aren't related. And you also have a much smaller chance of merge conflicts when you revert. Supposing you revert something that was pushed 3 days ago and there have been 6 changes since then, the bigger that change is, the harder it is to revert it because of other things that have happened on top of it. And then, of course, maybe most related to this topic is smaller pull requests are easier to review and quicker to review. Those are related, but not exactly the same thing. Some pull requests might be big but easy to review or quick to review because they're all white space changes or something, or some of these recent pull requests where we're changing import paths and it's pretty much a copy and paste. You might touch 100 files, but it's pretty quick to review.
I had a question regarding the first point.
Yeah.
Imagine that you are with a pull request for a feature, and in the code review you discover that there is an existing bug. What is the what is the best approach about handling that PR for the feature? Keep it on hold, close it again, and open it once the bug is solved. How is the normal flow for that?
Yeah, so in a related scenario that I see a lot is I'm working on a pull request, a feature, and I discover a bug even while I'm editing the code, and I'm tempted to fix it right then and there. What I typically do, and I think the same answer for the scenario I described and the one you described, is I would fix the bug in a separate pull request. Now, the way to do that, there's a couple ways. Usually what I do, usually what I do is I go ahead and create the bug fix as a separate commit in the same pull request. And that could be, whether that's because I discovered it during code review or I discovered it on my own during this coding. So I create a separate commit and I say, fix this bug. Then I will switch to my master branch and create a new branch from master for the bug fix, and I'll cherry pick that commit into that branch. And then I push that as a separate pull request and get that merged. Once that's merged, meanwhile, I'll leave my other pull request open and I might still be getting review on it. But then once that bug fix is merged, then I can rebase the feature on top of master, and magically, thanks to Git magic, that cherry pick commit just vanishes because it's already applied to master, and then you have a smaller pull request related to the feature. I do the same thing anytime I find myself with a bigger pull request than I want, whether it's because I have fixed 6 bugs in the same pull request, or I just realized that I could break this down into smaller pull requests. I will cherry pick 1 or 2 commits into another branch and make that as own pull request and then rebase. Does that answer the question sufficiently?
Yeah, especially the principal question that I asked is what is going on with the current PR. So keep it open is okay. So fine.
Yeah, exactly. So when is a pull request or merge request too big? And there's not a rule or a hard answer to this, but just some general guidelines to consider. And these are in our coding guidelines, but again, these aren't hard rules. It's just something to think about. More than 5 or 10 commits might be too big. It might not. It depends on what you're doing. More than 5 or 10 files changed might be too big. It might not, depends on what you're doing. It also depends a lot on what language and tools you're using. I mean, if you make one change that changes 100 snapshot test files, there's probably nothing wrong with that, right? And 100 or 200 lines of code might be too big, or it might not. Again, it depends on what you're doing. So don't look at any one of these as like a rule, but maybe if you hit 2 or 3 of these limits, then start to think, is there a way I can make this pull request smaller? This one's more of a rule. If you have unrelated changes, they probably don't belong in the same pull request. And this goes back to the reasons we just discussed about being able to revert cleanly, being able to review. I think it's also really nice to know as a reviewer when I'm looking at a pull request, it's nice to know if what I'm reviewing is intended to make a change or if it's intended to be a refactor, because I can review it with a different mindset in that case. If it's just a refactor, then when functionality changes, I can go, oh, that's probably wrong. This is meant to be a refactor. They didn't mean to start changing this functionality. So as a coder, I often will, in my descriptions, will say no functional changes or no functional changes intended, to sort of as a clue to whoever's reviewing it, that if they see that I made a functional change, that it was a mistake on my part. So that's another good reason to keep your refactors in separate pull request, because it makes it much easier to have that sort of mindset when you're going through it. So now this is sort of the nitty gritty. These are things I look for when I'm reviewing somebody's code. It's not necessarily an exhaustive list, but it's a fairly long list. What do you think? Should you look for proper formatting in a code review? Tabs versus spaces, cuddled versus uncuddled, else, and there's a million other things you could put on the list. In my opinion, no, you shouldn't check that in your code review, primarily because you should have a linter. And at least for our Go code, we do a good job of that. I think the front end code does the same. By now, I think you're using linting. I'm not 100% sure.
Yeah, we are using it.
Good. If anybody's not using a linter on your code base, please do that rather than fighting about it in pull request reviews, because that's just a waste of time. Just let a tool do that for you. Does the code work? This is another thing that more or less should not be part of your review, because your test should handle that for you. Of course, there are some exceptions, something that's difficult to test or can't be tested automatically, especially if you're in the front end or the mobile arena. That's a bigger consideration. But closely related to that, what should be part of your code review is, are the tests complete? So that kind of requires human intuition to determine that. I mean, there are tools, of course, that tell you if to tell you a percentage of code coverage or something like that. It could be branch coverage or lines coverage or something like that. Every single one of those tools you can tell it to lie. I mean, you can cheat and get a higher percentage than is meaningful. In other words, you can execute code in a test, but not actually test the result, for example. Or you might have a code that it's executed, but the test is not executed in ways that actually test it sufficiently. So don't rely on some tool telling you I got 100% coverage or whatever percent. Use your human brain to look at the tests in the code and validate. Are the useful test cases actually covered here? And by the way, consider that your tests are actual code. So they should be held to the same high standards. They should be readable. They should be modular. They should follow essentially good design principles and so on and so forth. Is the code readable? This is one of the main things I look for in code review. And I like this quote from Robert Martin. I assume many of you know Bob Martin. He's a fairly famous developer, and he writes books and does YouTube talks and always has a funny thing to say. But he says, one of his quotes here, the ratio of time spent reading versus writing code is over 10 to 1. We are constantly reading old code as part of the effort to write new code. Therefore, making it easy to read code makes it easier to write. So, this is one thing I look for a lot, like in interviews, and it's hard to get this in an interview, but maybe with a coding challenge. But it's more of an attitude than it is a technical skill. Do you write code for other people, or do you write code for yourself? And this is like the difference, in my opinion, between a good developer and sort of a cowboy coder type person who just, maybe they hack out 1,000 lines of code a minute, but it's hard to read and it's not maintainable. The one of the most important things in my opinion, for quality code is code that's easy to read, is easy to maintain, because for the exact same reason this quote talks about. I mean, not just the time it takes to read it though, but the time it takes to maintain it. I mean, code that is not well designed is really hard to modify. So writing code that is easy to read and easy to modify is one of the most important things we can do in code review, in my opinion. A really good sort of litmus test or heuristic I use when reviewing code is, if it doesn't make sense to me when I read it the first time, it probably needs to be refactored in some way. It might mean that it needs just more comments, or it needs, just to be made more clear. But whenever you read code, including my code, if you're reading my code and it doesn't make sense to you, that needs a comment in a code review, because it needs to make sense when you read it. I have a good friend who says that good code reads like poetry. And if my code that you're reading doesn't look like poetry to you, then it's bad code and it needs to be made more clear. And this relates to what I was just talking about too. Does the code follow good design principles? And I'm not going to talk a lot about what good design principles are right here. That's another topic. But and it also depends on what language and what framework you're using. But does the code follow principle? Good design principles is a great thing to look for in a code review. And is the Git history clean and readable? I think we overlook this a lot. But part of your merge request is the merge request. It's the commits. It's how many commits there are. It's the commit messages. All the metadata about your commit is also part of your merge request. So don't forget to look at that. And I'm not going to go into great detail here, but your commits should make sense. They should have good commit messages. Typo is not a good commit message, or fix or bug fix or whatever. Those are not good commit messages. They need to be descriptive. When somebody's reading your commit, they should know what you are intending to do. And then is the pull request or merge request properly scoped? And this goes back to those 4 reasons for code that I was talking about. It goes beyond that, but it includes those things. So, a merge request that has too many things happening, if you're adding 3 features at the same time, that's probably a bad merge request. If it's fixing too many bugs or whatever, it's too big. So keep it well scoped. Keep each merge request related. Is there anything I haven't talked about that you look for in code review that you think is important?
Maybe when there is a conflict in the comments of a specific stuff, and you have a lot of discussions and a lot of threads in the same comment, how to tackle that, for instance? You should talk on it by independent channel, like in Slack, or you should keep discussing that topic in the code review to allow other people to see the progress of the discussion, or what do you think about that topic?
It's a good question, and there's probably depends on the situation, but in general, I prefer to have those conversations in the pull request because it leaves a permanent record. If the conversation happens in Slack, then a year later, when somebody's looking at that and they're wondering why did they make this decision or whatever, there's no record. So if you leave it in GitLab or GitHub, if you leave that conversation in the pull request, then there's a record. And a year later, when somebody's trying to figure out why is this code arranged this way or whatever, they can look at the history and they can see the discussion. And of course, it's probably 1% of those discussions that ever are looked at in the history in the future. But for those 1%, it's really important that history is there, right? It's the same reason that clean Git history is important. Usually we don't care. Most of the time, you never look back at your Git history and see those commits that just say bug fix. Usually it doesn't matter. But when it does matter, it's important that you have good data there. So that's my general approach. Of course, there are exceptions. There are times when you need to have maybe a face-to-face conversation even, or a Zoom call to discuss something. It's just too cumbersome to discuss it in the pull request. So don't feel bad if you do that, of course. If you find yourself having long conversations in a pull request, though, it might be an indication that something isn't ready for a pull request. Maybe it needs to go back to the design stage, and so maybe reduce the scope of the existing pull request. Actually, I did this just recently. I had a conversation a couple days ago on a pull request between me and Pablo, and we were discussing changing timeouts on a CouchDB changes feed, and I decided that in the interest of time, I would just kind of go back to the old behavior and merge that, rather than continuing the discussion, because it was just taking longer than necessary. And the change we were discussing wasn't really related to what the pull request was meant to be doing in the first place. So just consider that as a potential signal that maybe the scope of the pull request could be narrowed somehow. Anything else you guys look for that I haven't talked about?
I think I always try to focus on when something maybe is not as readable as it should be, the comments in the code and these kind of things. Trying to help whenever whoever is going to read the code later, things that can improve that. Please comment this in order to explain what you've done here.
Yeah, I'm going to talk more about comments in a moment, but yeah, that's a really good point. Good comments are useful.
Like the code does what it's supposed to do, right? Like it might work, it might pass a test, it might be clean, but it needs to do what the guy is intending to do.
Sure. Yeah, that's really good. Yeah, you might say that this pull request adds a widget, but it doesn't add a widget. Then you're
Correct.
probably, even if the test passed, it's not right. Yeah, very good. Okay, I'm going to go through a few examples. These are all made-up examples to protect the innocent or the guilty, whatever. But I think they're realistic examples. Let's talk about naming things. What do you think about, some of you already know my opinion on this particular example, check foo, because I've definitely commented on it in some pull request reviews. Is this a good name or a bad name, and why?
It's a bad name because check could mean a lot of different topics. What things are you checking?
Exactly. And we have had a lot of check named functions in our code. I don't think we have many left, but whenever I see one, I scream about it. Don't use the word check in your function names. Use something that is clear what it means. Foo is valid is maybe a good one. Probably returns a Boolean in that case, or maybe validate foo. Depending on the language you're using, that may or may not be a good name. In Go, it's common. We commonly use something like validate foo, and it returns an error if there's some validation failure. Depending on the language and framework, you might use something else, but the point is make sure that it's clear what the function does. If I have something called check foo, I don't know if it's going to return an error or a Boolean, or maybe it returns nothing and it just does some check in the background, and I expect that by telling it to check something, it's good. How about this one? For X in names.
For me, it's bad also. Although I saw a lot of, especially in backend code, like very short names even for outside loops that I personally don't like, but maybe it's more, I'm used to do that. I prefer to put longer names, longer in this case, and not C, X, or Y, or whatever.
To me, it depends on the context. If you are in this case, if the loop is very small, it's not so important the name, because you are going to see what X means, but it's obviously better if you if you name it, for example, for name in names, like the singular of the range.
Yeah, I agree with both of you. I think in this case, name is the obvious name for the variable. There are times when a one-letter variable might make sense. I'll talk about that in a moment. How about this one? Good or bad, and why?
For me, it's bad because it's repetitive. I mean, if you have already the names prefix, you know that you're adding a new name. You don't need the add name. Just with add, it should be good enough.
I agree completely. That's exactly my suggestion too. Just do add. Now, of course, if it was not names, if it was like order, and then you had add name, maybe that makes sense because you're adding a name to an order. But if it's names, it's probably a collection of names, so you don't need to be repetitive. All right, here's another one-letter variable, but it's not obvious that it's a name. So I think we already discussed this. Maybe we don't need to open up the mic here, but I gave this a question mark. I think it could be good or bad depending on the context. And I agree with what Pablo said. You know, if it's a short for loop, for example, I might make sense. If this declaration is then used for 3 or 4 pages, it's probably a bad name because I don't know what I means. All right, how about this one? We have 2 functions here. One's called make foo and one's called create bar. Is this good or bad, and why?
There's no consistency here.
Exactly.
Maybe we should go for one of them.
Yeah, pick one or the other. How about this one? I think we already know the answer.
Yeah.
Just spell it out already, come on. Anything else about naming that drives you guys nuts?
For me, general rule, as I said, is it's better to choose meaningful names over not meaningful names, and it depends a lot on the context. If the variable is going to be used in a very narrow scope, it's okay to use short names. But as if we are going to use that variable, for example, outside from the current scope or in a bigger scope, it's essential that have a long, meaningful name.
Absolutely.
And also recently I saw a variable name or type called meta collection. Depends in this scenario, metadata is a collection. And why we need to suffix with collection too, and sometimes we need to check the type too before naming the variable. In
Yeah,
case of array and others.
Especially if you are using a language that is hard type, you don't want to add the type into the suffix because the compiler is doing that check for you.
There's of course a lot more we could talk about naming. I mean, we just talked about variables and functions here. You can also talk about package names and class names and all this stuff. I trust that you guys can apply common sense to that and challenge each other if you see some WTF names. All right, code comments. Well, Jorge brought up. So here's 2 options that kind of do the same thing. And my point here is prefer self-documenting code. So if you can get away without a comment, that's the best. That goes back to the idea of code that reads like poetry. So in my opinion, the second version here is better because the comments are implicit. They don't need to be stated as comments. Does that make sense? Comments tend to get out of sync. How many of you have seen a comment that says 5-second delay or 5-second timeout, and then the code right below it says 10 seconds or similar? I see that all the time. I just saw it again yesterday. It happens all the time.
Successful code comments something. Okay, I think is a conditional. If for some reason the guy comment success.
Yeah, I think I know who did that. General rule of thumb: a comment should explain why something is happening, not what is happening. So if you have a confusing function, you can explain why are we doing this thing, and I'll talk about this more in a moment, but not what are you doing. The code should tell you what it's doing. You should be able to tell that by reading the code. So, and this makes that an example, right? Maybe the first example, it's not obvious that we're setting defaults, except the default value kind of makes that clear. But in the second case, it's absolutely obvious we're setting defaults because that's what the function's called. Now, if you have a question of why are we setting defaults, then a comment might be appropriate. So here's another example. It's obvious. This is like the success example you just mentioned. It's obvious. We need to return a nil error. That means success by definition. You don't need to tell me that. So just get rid of the comment. And here's the same thing I talked about. Default 10 minutes, but it actually is 20 minutes. Just get rid of the comment. It's not necessary. We know what that means. And comments should be in the right place. That's one reason comments are harmful too, is they tend to fall away. If you insert new code, maybe you don't realize there's a comment there, and that the comment is no longer where it belongs. So here the comment probably belongs at the if statement, not above the variable declarations, right? This comment is based on an actual comment I remember from several years ago, where my colleague wrote code, and his comment was, "Don't change this code unless you really know what's going on. I spent several hours working out this logic." And all that comment really served to do was scare me from touching the code. It didn't explain that the logic was correct. Like I would rather see unit tests to explain that prove the logic is correct. So if I change something, I know that it's working. But it also didn't point to his proof. Like if he had written a document explaining what he did, he could have put a link to that document in that comment rather than just saying, "Don't touch it, I know what I'm doing." And then here again, the why, not how. We don't need a comment that says add 10% tax. We can read the code, but maybe explaining why we're adding a 10% tax is useful.
What do you think about the to-do comment?
Yeah, that's a good question. I think they're useful in conjunction with an issue. In other words, it's useful. The best way to use a to-do comment, in my opinion, is to have either a bug number or a link to an issue. So to-do and then your GitLab issue link, and that's useful because then when you get to that GitLab issue, it's easy to do a grep to find where that code needs to be changed. To-do comments by themselves are almost worthless because nobody ever, or almost never, sits down and looks through the code and goes, "Oh, what could I do today? Let me look for to-do comments." I mean, maybe somebody when they're bored does that, but it's very rare. Most to-do comments just rot. So if you create a to-do comment, I suggest adding a link to the issue that tracks it, and then it's useful as a reverse lookup to find the code rather than the comment itself providing value. An exception might be if the to-do explains some sort of logic that you're going to do that will be useful when you're editing the code in the future. But a simple to-do to say, refactor this to be faster probably isn't useful unless it's linking to an issue. I've worked on teams in the past where we actually had part of our linting configuration would prohibit to-do comments that didn't reference an issue number or a link or something like that. I know some people who don't like short functions. They think they're a waste. Like if I can do that in one line, why would I put that in a function? I'll just do it in line. But I don't like to think of it that way. So in my view, the shortest useful function is a single line. In some rare cases, maybe even 0 lines. Maybe an empty function is useful, but that's probably only useful like if you're testing and you need a stub. So don't feel bad about making small functions, and the same with pull requests. A single character pull request is perfect if it serves a purpose. Don't just add junk to your pull request to make it bigger so you feel like you're doing something useful. Small is good.
About function size, I feel like sometimes it's good when you have a really big function and you have problems to understand what the function is doing. Sometimes I think that it's really helpful to break big functions into a lot of smaller ones, which helps to make code easier to understand, and also it makes the code kind of self-documenting, because you would actually have a big function that is divided into smaller tasks, and it's a lot easier to read and to follow. Just wanted to.
I definitely agree. Absolutely. Linus Torvalds used to be famous for his opinion that every function should fit on a screen. And this is back when people were using 80 by 25 screens. So by his rule, no function should be more than 25 lines long. On modern screens, I suppose that literal rule doesn't make sense. But I tend to agree. Short functions are best, and the shorter the better. Goes back to looking like poetry. I mean, I guess some people like to read really long poems if you're reading the Iliad or something. But generally, make your functions small, break big ones down into small ones.
And also follow the solid principles. Most of the case, short functions, single responsibility stuff, and
yeah, that's good. I mean, if you have a function that has an and in its name, it's probably too big, because each function should do generally one thing. All right, low complexity. And I know a lot of you guys already point these things out in your code reviews, so this isn't to say that you're not doing it right, but just a reminder. Do early returns when possible. That's a really simple way to reduce complexity. It doesn't literally reduce complexity. The code still is just as complex, but it looks visually less complex to have less indentation, and it's less of a cognitive burden because you can just easily dismiss. If you have an early return, you can just easily dismiss the state in your mind about what happens at that point. If you have 50 lines of code in your if case, then you kind of have to keep two code paths in your head as you're reviewing the code. So also avoid return else. Actually, Go prohibits this, or the linters do. They'll complain if you do this, but avoid it anyway, even if you're not using Go. There's just no reason to have a return and then an else, because the else is by definition not going to happen in the if case. For that matter, maybe avoid else. Usually an else can be rewritten as a function that does an early return. So this goes back to what Gaston just said. If you have a big function, turn it into smaller ones. So this is one example where you could do that, and then you can get rid of the else entirely. And maybe it's a matter of opinion, but in my opinion, the second version is easier to read than the first one. Never mind that calculate x isn't a very good function name. Hopefully it's doing something useful. And for that matter, maybe avoid if. There's a really good YouTube presentation called If Considered Harmful, and it explains when ifs are harmful and how to avoid them. And so it's not that all ifs are harmful, but it's when you have duplicate ifs that is harmful. So you check the same condition in more than one place, it tends to just breed thousands of bugs. I won't talk about it more here. I'll give you the link. I encourage you all to watch it. Use fewer indentation levels. 2 or 3 is usually a maximum. Again, it's going to depend on the language and framework you're using. Avoid magic. I don't know. Has anybody else here programmed in Perl before? I was a Perl developer for 10 years or so before I started doing Go.
Yay.
I've done some Perl too.
Yeah, I'm sorry. Perl is so full of magic. There are people who love Perl, and I used to be one of those people. But it's just so full of these little subtle things. You can cram so much stuff into 5 characters, but nobody can read it afterwards. Don't do that. Don't try to be clever. That goes against what we were talking about earlier of making your code as readable and maintainable as possible. And that's kind of what this whole slide is about. Compound conditionals, especially when you have like if this and that, and then parentheses or this or that, and more parentheses and this and that, that just gets really hard to read. Break it into a function and make it easier. Regular expressions, especially the super fancy ones you find in Perl, are almost always magic, hard to read. Esoteric language features, Go doesn't have a lot of those by design, but many languages do. Operator overloading is an example. Global state can seem like magic since something can change and you don't know why or where. And then again, just avoid cleverness when possible. Be explicit rather than clever.
In JavaScript, I like reduce, and that works like magic, actually.
Yeah. I think whether reduce is considered magic depends on your paradigm, because that's a functional programming paradigm. So if you come from Haskell or something, you're probably going to think that that's just normal. But I could see why it would seem like magic. Yeah. Good design principles are something we should look for. I'm going to kind of breeze through this. Solid principles are a good guideline. They aren't gospel truth in the sense that every single one of them always has to be followed, and it depends a lot on what language and framework you're using to what extent all of those principles are necessary. Solid was developed around object-oriented programming in particular. So if you're not using object-oriented code, then some of them will make a little bit less sense. But in general, it's still they're based on good principles. Domain-driven design is often a good idea. It's just a sort of suggestion. Just zip through these here. Don't repeat yourself. Everybody loves this one, right? Does anybody hate DRY? Well, the next one is wet. Write everything twice. Both of these are good practices, in my opinion. Depends on when you're using them. So just be careful. Not be careful, but be mindful. Make sure you know why you're doing what you're doing. If you repeat yourself, know why. If you abstract something away, make sure you know why. And you ain't going to need it. Closely related to premature optimization and over-engineering. Only write the code you need, unless you really know you're going to need it. Don't waste a lot of time and effort adding complexity that just has to be maintained before it's used. I think that's the last slide. Is there anything I missed?
Maybe architectural changing over the time on pull request. I mean, it's usually not easy to see, or to see why, for example, a new way of doing things is important when you are reviewing a pull request or merge request. So it's good, for example, to have a previous discussion on why do you need to change some architecture of the system, and link in the pull request or in the merge request that discussion.
That's great. Yeah. Yeah. So imagine you see a pull request with a whole bunch of refactoring without an explanation. That's probably it's really hard to review that because you don't know what the purpose is, and there may be a good reason. And hopefully it's one of the those refactors we talked about at the beginning. Making it easier to read or making it perform better. But yeah, and so that's also related to the pull request metadata. Make sure that the pull request is clearly described. It should have a good title and it should have a good description if necessary. Not all of them need a long description if it's pretty obvious. But if you're doing a big architectural change, make sure you have a good description of your merge request. And if you're reviewing one that doesn't, do not be afraid to ask for one. You can just stop the review and leave a comment that says, what does this pull request do? And that's a good enough review to start with. You don't have to go through and look at all the lines of code first. Make sure you know what the pull request is aiming to do. And of course, there are times when I think it's really easy to do this. I think we do this a lot at Lana, where we focus on the details without looking at the big picture. And part of that's because we have a microservices architecture, and our principal architect is no longer with us. So it's a little bit harder sometimes to get a view of what the big picture is. And so we might be doing some sort of micro optimization, and maybe we're making. I'll just pick on NATS since I know that's something we're discussing lately. But maybe we're optimizing some NATS aspect of something, and really we should be discussing: should we be using NATS here at all, or is there a better approach? We might have the most beautiful poetry style code about NATS, but if we shouldn't be using NATS, then it doesn't really matter, does it? So I think there's at least two aspects here. One is when you're creating a pull request that does an architectural change or a refactor, state why, and as Pablo mentioned, link to discussion about it. If that discussion hasn't happened and you're just making up architectural decisions on your own, be prepared to get some pushback. That's not to say you should never do it. You might have a good reason, but just be prepared for somebody to challenge you and be prepared with an explanation. And then on the other side, if you see code smells that are hard to explain with that one's harder to state clearly, but sometimes you see things in the code that just don't feel right and you don't know why. That might be an indication to step back and consider, does a bigger change need to be made on an architectural or design level? Again, the NATS examples, we've been fighting NATS bugs for a while. And of course, I don't know the answer. Maybe NATS is the right answer, but we need to have the conversation and determine if NATS is the correct approach or something else. Anything else? Any other questions or comments?
Yeah, me. I previously worked in a company that likes a single point of return in functions. I mean, if you write a lot of if, you save the variable that should be returned, and at the last, return that variable. Is it a good practice?
In my opinion, it's a bad practice, but that's my opinion. And the main reason I consider it a bad practice is because it increases the cognitive load on anyone reading your code. I prefer early returns because then I can just mentally, as I'm reading that code, I can just dismiss any state immediately in my head. I don't have to keep in mind, oh yeah, I still have these 3 variables that might be used later. I know that's my opinion, and I think the only possible answers to that question are opinion answers. There's no objective truth, but I have my reasons for my answer, and I'm sure that your former colleagues have reasons for theirs too. If we had a discussion about it, maybe one of us would convince the other. I don't know. Does anybody else have a different opinion?
I agree with you, John, and also my brain is not a compiler, so
What?
it's difficult to understand this scenario that Jose explained to us.
Yeah.
To understand, okay, at one attribution, in the end return the variable. It's difficult to follow the.
Yeah, I have heard people state that opinion before, that you should have only a single return, and I've heard it. I've heard some people claim that it is an obsolete mathematical sort of ideology. That that idea comes from pure functional programming, but that even most modern functional programmers don't hold to that same principle. Certainly not if you're not doing a functional language. Maybe if you're using Haskell or something, maybe it makes sense. But that's such a different paradigm that I don't think it really applies to Go, Java, or JavaScript, or Swift, or any languages we're using. But again, I think it's opinion. I don't think there's an objective answer.